Hi friends, welcome to my channel. Myself is Sangeeta Jayan from Placement Door Academy. Today we will discuss the important parameters determining the performance of cooling towers like cooling tower range, cooling tower approach, cooling tower effectiveness, evaporation loss, heat load calculation, cycle of concentration that is COC, drift loss, blowdown loss makeup water calculation, and finally we'll know the most common reason for low cooling tower efficiency. Now we will discuss how to calculate the range of cooling tower. So range is the difference between cooling water inlet temperature and cooling water outlet temperature. Here is the calculation. If hot water inlet temperature is 43 degrees Celsius and cold water temperature is 33 degrees Celsius, then range will be 43 minus 33, that is 10 degrees Celsius. Now how to calculate the approach of cooling tower? So approach is the difference between cooling tower cold water temperature and ambient wet bulb temperature. Here is the calculation. If cooling tower cold water temperature is 33 degrees Celsius and ambient wet bulb temperature is 27 degrees Celsius, then approach will be 33 minus 27, that is 6 degrees Celsius. Here we will discuss how to calculate the cooling tower effectiveness or efficiency. So cooling tower effectiveness is equal to range divided by range plus approach. Here is the calculation. If range is 10 degrees Celsius and approach is 6 degrees Celsius, as we have already calculated, then cooling tower effectiveness will 10 divided by 10 plus 6 is equal to 62.5%. Now we will calculate the cooling tower heat load. So cooling tower heat load is mass of cooling water flow into specific heat of water into range of cooling tower. Here is the calculation. If water circulation rate is 10,000 cubic meters per hour, we will convert it to kg per hour by multiplying it with 1000. As you know, specific heat of water is 1 kilocalorie per kg Celsius and range, as we have calculated earlier, is 10 degrees Celsius. Then cooling tower heat load is equal to 33068 TR. TR is the ton of refrigeration. Now we will calculate the cooling tower evaporation loss. So cooling tower evaporation loss is 0.00085 into 1.8 into circulation rate in cubic meter per hour into range of cooling tower. Here is the calculation. As we have considered water circulation rate is 10,000 cubic meters per hour and range as calculated is 10 degrees Celsius, then evaporation loss will be 153 cubic meters per hour. Here we will calculate the cycles of concentration, also known as COC. So COC is the ratio of dissolved solids in circulating water to dissolved solids in makeup water. Here is the calculation. So if dissolved solids in circulating water is 1500 and dissolved solids in makeup water is 250, then COC will be 1500 divided by 250, that is 6. Now we will calculate the blowdown loss in cooling tower. So blowdown loss will be evaporation loss divided by COC minus 1. Here is the calculation. So if evaporation loss as calculated earlier is 153 cubic meters per hour and COC as calculated earlier is 6, then blowdown loss will be 153 divided by 6 minus 1, that is 30.6 cubic meters per hour. Now what is drift loss in cooling tower? So drift loss is 0.005% of circulating water. Here is the calculation. As we have considered circulating water equals to 10,000 cubic meters per hour, then drift loss will be 0.5 cubic meters per hour. Now we will calculate makeup water in cooling tower. So makeup water is evaporation loss plus blowdown loss plus drift loss. Here is the calculation. As we have already calculated the evaporation loss equals to 153 cubic meter per hour. Blowdown loss is 30.6 cubic meter per hour and drift loss is 0.5 cubic meters per hour. So makeup water will be 153 plus 30.6 plus 0.5, that is 184.1 cubic meter per hour. So liquid to gas ratio is the ratio between the water and the air mass flow rates. Thermodynamics also dictate that the heat removed from the water must be equal to the heat absorbed by the surrounding air, that is L into T1 minus T2 is equal to G into H2 minus H1. L to G ratio will be H2 minus H1 divided by T1 minus T2, where L to G ratio is liquid to gas mass flow ratio in kg per kg. T1 is hot water temperature in degrees Celsius, T2 is cold water temperature in degrees Celsius, H2 is enthalpy of air-water vapor mixture at exhaust wet bulb temperature, and H1 is enthalpy of air-water vapor mixture at inlet wet bulb temperature. Now, my dear friends, what checks are to be done if we have low cooling tower efficiency? First, check scaling, as scaling reduces the heat transfer efficiency of fill media. Then growth of algae, bacteria and other microorganisms within the cooling tower. Fouling the fill media restricts the water flow and decreases the cooling tower efficiency. Also, uneven water distribution over the fill media can lead to inefficient cooling, and also insufficient water flow decreases the contact time between water and air, reducing the heat transfer efficiency. If you find this tutorial informative, please like and subscribe this channel and let us know your thoughts in the comments section. Thanks you so much for watching. See you in the next video.